Welcome. This video will delve into the advanced features of GitLab, focusing on continuous integration, continuous deployment, and its capabilities as a comprehensive DevOps platform. GitLab is more than just a code repository. It offers a suite of tools to streamline your entire software development lifecycle. We will be exploring CI/CD pipelines, DevOps metrics, and security features. Continuous integration and continuous delivery pipelines automate your software delivery process, allowing for faster and more reliable releases. DevOps metrics provide insights into your team's performance, helping you identify areas for improvement. Security features help you to identify and address vulnerabilities in your code early in the development process. GitLab's built-in continuous integration and continuous deployment system automates your software delivery process. The key features of GitLab CI/CD are automated testing and deployment, configuration as code with .gitlab-ci.yml files, integration with containers and Kubernetes, customizable pipeline stages and jobs, and detailed pipeline visualization. As you can see here in the diagram, the pipeline stages include building, testing, security, deployment, and production. The build stage compiles the code. The test stage runs tests. The security stage performs static application security testing and dynamic application security testing. The deployment stage deploys to staging, and then the final stage is production release. The .gitlab-ci.yml file defines your continuous integration and continuous delivery pipeline structure, including stages, jobs, and their dependencies. Key components include stages, which define the pipeline sequence, jobs, which define what to execute, scripts, which contain the actual commands, and artifacts, which pass data between jobs. Some best practices include keeping configurations simple at first, using variables for reusable values, and validating your YAML syntax. Here is a sample YAML file. Stages are build, test, and deploy. Under the build job, the stage is build, and the script contains commands, such as echo building the application, npm install, and npm run build. Let us explore the common job types and their configurations. Some common job types include test jobs, which run unit tests, integration tests, and other automated testing to validate code quality. Lint jobs, which check code style, formatting, and potential errors using static code analysis tools. Deploy jobs, which deploy applications to different environments like staging and production, and security jobs, which run security scans like static application security testing, dynamic application security testing, dependency scanning, and container scanning. Here are some example job configurations. In a test job example, the variable unit test, the stage is test, and the script is npm run test. In a lint code example, the variable lint code, the stage is test, and the script is npm run lint. For the deploy staging job, the variable is deploy staging, the stage is deploy, the script is echo deploying to staging, and the environment name is staging. Variables are useful to make pipelines flexible and secure. There are 3 types of variables to use: predefined variables, project variables, and file variables. Predefined variables are automatically provided by GitLab with information about the pipeline and repository. Some examples include CI commit SHA, CI job ID, and CI project path. Project variables are custom variables defined in the project settings and are ideal for secrets and environment-specific values. Some examples include API token, database URL, and deployment server. File variables are defined directly in the .gitlab-ci.yml file and are best for non-sensitive configurations. Some examples include app version, build type, and environment. Here are variables defined in the .gitlab-ci.yml file. The keyword variables with the app version set to 1.0.0 and the node environment set to production. Under the build job, the stage is built and the script echoes building commit CI commit SHA, echoes app version, and echoes deploying to deployment server. Artifacts are files created during a job that can be passed to subsequent jobs or downloaded after the pipeline completes. Some common use cases for artifacts include build outputs such as compiled binaries and packages, test reports and coverage data, documentation files, and deployment packages. Some configuration options include paths, which are the files to include, expire in, which specifies how long to keep artifacts, when, which are the conditions for creating artifacts, and reports, which are special artifact types. Here is a diagram of the artifacts. The build job compiles code and passes the build directory as an artifact. The test job then tests the application and passes the test report.xml as an artifact. Finally, the deploy job deploys the app. GitLab offers integrated security scanning in your continuous integration and continuous delivery pipeline. Static Application Security Testing, or SAST, analyzes your source code for known vulnerabilities, detects structured query language injection, cross-site scripting, and more, and contains language-specific analyzers. To include it in your .GitLab CI.yml file, include the template security/SAST GitLab CI.yml. Dynamic Application Security Testing, or DAST, scans your running application for vulnerabilities, tests deployed applications, and finds runtime vulnerabilities. To include it in your .GitLab CI.yml file, include the template security/DAST GitLab CI.yml. Dependency scanning analyzes your dependencies for known vulnerabilities in third-party libraries, checks package managers such as npm and pip, and provides vulnerability reports. To include it in your .GitLab CI.yml file, include the template security/dependency scanning GitLab CI.yml. Container scanning scans container images for known vulnerabilities in the operating system packages, checks Docker images, and identifies operating system level vulnerabilities. To include it in your .GitLab CI.yml file, include the template security/container scanning GitLab CI.yml. GitLab environments are targets for deployments that represent different stages in your software delivery workflow. Key benefits include tracking deployments across environments, viewing deployment history, monitoring environment status, and manual or automatic deployments. To configure, define environments in your .GitLab CI.yml file. As shown in the example under deploy staging, the stage is deploy, the script is /deploy.sh staging, the environment name is staging, and the URL is specified as https://staging.example.com. The deployment flow typically involves development, staging, and production environments. Development has automatic deployments for each commit. Staging has automatic deployments from the main branch, and production involves manual deployment with approval. GitLab provides metrics to measure and improve your DevOps performance. Some of these metrics include lead time, deployment frequency, change failure rate, and mean time to recovery. Lead time measures the time from code commit to production deployment, identifies bottlenecks in delivery, and helps optimize workflow efficiency. Deployment frequency measures how often you deploy code to production environments, indicates team agility, and reflects continuous integration and continuous delivery maturity. Change failure rate is the percentage of deployments that result in failures or incidents, measures code quality, and indicates testing effectiveness. Mean time to recovery is the average time to restore service after a failure, measures incident response, and reflects operational resilience. GitLab's integrated metrics help teams measure, analyze, and improve their DevOps performance over time. If you like this video, hit that like button and don't forget to subscribe. Visit codelucky.com for more such useful content.